Stars implode, planets grow cold. Catastrophe is the metabolism of the universe. I can fight monsters, I can't fight physics.
We've got this question from M about a transformer. So figure 21 shows a transformer used to power a lamp using the mains electricity supply. So this is a step-down transformer. So how can I tell? There's more turns on the primary compared to the secondary. So that's your knowledge. So the number of turns on the primary is greater than the number of turns on the secondary. The voltage on the primary should be greater than the voltage on the secondary because it's a step down. It's stepping down the voltage, but by stepping down the voltage, it's stepping up the current. So the current on the primary is less than the current on the secondary. So that's your knowledge. Then you got your two formulas, your go-to formulas. So NP over NS is equal to VP over VS. Or you can write it with the S's on top, that's not a problem. And then you got your power formula, power on the primary equals power on the secondary, which looks like the one they want us to use. So IPVP is equal to ISVS because power is IV. So those are your formulas, that's your theory. So 8.2, determine the current in the secondary coil when the power output of the transformer is 6.9 watts. So what you wrote there is a good starting point. So you got power in the primary equals power on the secondary because we're assuming 100% efficient. So there's no energy loss. So you could have, now the issue you got here, so you've got VP, okay, you got NP, you've got NS. You could work out VS, sorry. So we could work out VS. Now you got two choices here. You could use the formula, the transformer formula, or you could do what I told you is probably easier because it's easy to visualize. So if you've got 2000 turns and you've got 40 turns here, and then obviously you've got 230 volts. Well, if you work at the scale factor, if you do 2000, well, what did you do? You divided by 50. So if you do 2000 divided by 40, you get 50. That means the voltage does exactly the same. So that you have to divide by 52. So if I just do that on the calculator, so 230 divided by 50, so that gives me 4.6 volts. Now that makes sense because it's a step down transformer. I'm expecting the voltage to be lower on the secondary by the same scale factor. Now you're probably thinking, why didn't I use this formula? I essentially have. Okay, so I've essentially done the ratios because this is all this is, it's a ratio formula. Now they've just told me the secondary power on the secondary is equal to 6.9 watts. Now, what do we know about power? Power on the secondary is equal to the current of the secondary times the voltage of the secondary, and we've just worked out the voltage of the secondary. So 6.9 watts is equal to current on the secondary multiplied by voltage on the secondary. So you can work out the current on the secondary, which is 6.9 over 4.6. So let's just put that in the calculator. So 6.9 divided by answer. So that gives me 1.5 amps. Okay, so that's how you work out the current in the secondary. If you wanted to work out the current in the primary now, you could anyway, because if you know the power on the secondary is 6.9 watts, you know the power on the primary is 6.9 watts. Okay, so therefore you could do power on the primary equals current on the primary times voltage on the primary, which is this one here. Okay, or you could just do the ratio. If the current, if the voltage goes down by a factor of 50, the current increases by a factor of 50. So when you go from secondary to primary current, you just divide by 50 because the arrow's going in the opposite way. Okay, hopefully that answers your question for that one.